Hi, my name is Norman. In part 2, I didn't really show my face. Did you notice? Well, I did not, at least until I was looking for a thumbnail. So I took a frame from this video instead. Ha! Got him. Yeah, anyway, let's wrap this puppy up. So next up, we gotta hook up all those tiny little switches here. For this keyboard here, we are going to build a matrix. The microcontroller which I plan to use has a lot of spare inputs, so I don't need to worry that much about inputs, and I don't need to find out which matrix is the best or requires the least amount of inputs. For this one, I'm going to keep it simple, so you can see here 1, 2, 3, 4, 5 that way, and it's 15, just believe me, in that way. I think 1, 2, 3, 15, yes. So it's 5 by 15 matrix. It requires 20 pins, of course. So yeah, we're gonna hook up the matrix that way to keep it simple and also clean, which is very important to me. I've done hand wiring a couple of times already, and I always end up following that one instruction, and it's a very good instruction. I'll link it down below in the description. We're just gonna follow it because it's been proven to me that it works. We're gonna start with the diodes. So this little tiny diode here, it has a black marking on one side and no marking on the other side, and we have to bend around the side without the marking. I'm just going to take my tweezers, grab them, and then bend it at a 90-degree angle. That way I'm always going to have the exact distance between bends and no bends. And you don't need to worry that much about a 90-degree angle because actually we are going to make a loop. So I hope those are 67, got some spares. So yeah, if those aren't enough, you can make some more. So now that we got the bend, yeah, we need to make a loop. I'm still going to take my tweezers here. Maybe I'm switching to those. Yeah, that's a lot better. I'm almost done, and well, I found the best way to do that is that you grab it right underneath the angle which I just bent earlier, and then you just press it down, and then you got your loop. That's the easiest way to make these bends, and because I just found it out to the end or midway, and the earlier ones are kind of weird, I'm going to mix them up so that the bending technique is going to be more or less random, and you're not going to see a pattern. Before we install them, we need to clip off these ends here so that we're only left with the loop. And once that's done, we can finally start with the first soldering operations. I put my keyboard here on a piece of MDF because the rotary encoder, well, it's not flush with the switches. So now we need to place all the diodes facing up, and once we start that, there's no way back. Okay, one done, 66 to go, right? So this is where we are right now. As you can tell here on the top right, which is going to be the top left later, we have the rotary encoder, and as you can see, I just act as if the rotary encoder is a regular switch because, well, it does have a click, and that's the easiest way to incorporate that into the layout. Yeah, the software will think that the rotary encoder here is actually just the same as a switch. So yeah, that's great. One thing you notice that I also added a little bit of electrical tape here. Yeah, because there's a metal surface, and yeah, that's going to prevent any shorts or false signals. And now we have a very interesting technique. We're gonna use single core wires for all the wiring here in the matrix. Later I want my microcontroller to be here on the right hand side. So I gotta think and flip, so I need to have cables on the left hand side. That doesn't matter too much because, well, I can always add more cables by soldering, but yeah, I'm gonna save a little bit of work if we just, you know, have the extra cable on the left side here. So I think that's about enough. I'm gonna just cut it. On the website that guy has a different type of wire stripper. This one is actually just to strip off the ends of a wire, and the guy has actually also can strip wires in between the wire, if that makes any sense. So I need to hack my way around a little bit. Let's see if it works. Of course it didn't. I mean, it sort of worked, right? So ideally the entire rest of the wire would be pushed back, but of course that doesn't work, right? So we're just gonna pull it off because we are going to start from the other side. For whatever reason, I just feel like the insulation will be pushed back a little bit easier that way. Maybe I can add a bend here so that the insulation doesn't glide as easily. I don't know what happened. Yeah, here's still the wire, so I think the insulation moved all the way to that side. I think you can see what we're doing here. We're just moving the insulation of the wire and exposing the wire so that we can solder on the diodes here. So that's a really, really nice and clean way to do that, because that way you don't have unnecessarily exposed wire. Oops, I messed up. Let's see if we can fix that. Nope. Okay, new one. Okay, and now for a magic trick. We're going to take a diode, and I think I'm just going to take pliers here and fold them over one by one. We'll take the first one, and then we can clip it off. These cheap wire cutters. Okay, rinse and repeat. This is how far we got. Yeah, it looks like a lot of things happened, but basically I just finished off the matrix. The columns work in the exact same way as the rows, and you've seen me doing the rows. Only difference is that you don't need the diodes, of course. They're just going to be connected in a vertical way, and then one wire for each column is going all the way to your right. Is it left, right? I don't know. It's mirrored and everything. My brain is melting because I've been working all day. Yeah, I think that's your left. Anyway, also those 2-3 cables dangling around here are the rotary signals. So the rotary encoder is also now having a wire going all the way to that side. On this side, this is where I plan to have my controller. Speaking of the controller, this is a Teensy 4.0. So the Teensy board is actually a very kind of popular choice. Usually people go with the Teensy 2.0. Also a very popular choice is the Pro Micro or you know, the Elite C. I went with the Teensy because not only it has a lot more ins and outs, which I require for that board, but also this thing has 600 megahertz. And you know, the Pro Micro only has 16 megahertz. So this thing is a lot faster than the Pro Micro, so it will handle my crappy coding and also, you know, doing graphic stuff on the display, which I'm planning to use. So of course, when you buy a Teensy, it usually does not come like this. It's just the board itself. What I did was using this kind of strip board here and making a breakout board for me. Oops. Yeah, I had very bad experience with soldering directly into the microcontroller. So basically, yeah, it would work. I could just, you know, solder all those cables here. I could solder them directly into the microcontroller. But now with having these JST connectors here on the side, I can just change wiring without soldering and desoldering. Let's hope that the extra work here is going to save me some nerves later when I need to change the wiring. So for the frame, I designed and 3D printed this 3-piece puzzle here. As you can see, it's going to slide in like so. More, it's going to slide. I said slide in. Okay. And then it's more or less, well, it's holding together. Before we put on the electronics and all that, we need to add some threaded brass inserts. And if you haven't heard of threaded brass inserts, it's about time, seriously. Because these things are the best things to ever happen to 3D printing since 3D printing. So they are exactly what their name describes. So it's a little piece here. This one is for an M3 screw. And it's a brass insert with a thread inside. The basic idea is that you heat it up and then you can press it into your 3D printed piece and they hold up surprisingly well. It's a very, very secure and tight way of tightening things, yeah. There are two different types of threaded brass inserts. Here's this type and there's another type. And by type, I mean shape. You can tell already this one is very expensive because it is for some reason. And here is the same, but in a lot cheaper, like almost a fifth of the price. If you're buying threaded brass inserts, I would definitely go with the more expensive one. You can see here there's a little nudge. And this thing here will make it a lot easier to actually insert that thing precisely. So if you have a symmetrical threaded brass insert, it's going to be really hard because usually that thing is a lot larger than the hole you want to put it in, because that's how they work. You melt it in. And if you have both sides, both ends being big, I think you can imagine it's really, really hard to actually find the hole. But with those here, you can actually insert them already partially with, by that little millimeter or 1.5, and then press it in with the heat. Unfortunately today we're going to need both, so we're going to take the expensive ones for the larger holes, and I need M2 holes here for obviously for smaller holes. 6 of those M2s and a lot more of those M3s. So again, I'm going to show you, these are the M3 threaded brass inserts with the more expensive ones. I can just put them into the hole here, and of course I messed up. That's going to make it a little bit harder. Okay, that's kind of awkward. Yeah, I designed without thinking, so we have a little problem here. It's gonna work, no worries, but we're gonna have, with those good ones, we're gonna have the same problems as with the bad ones, which is the hole is too tight, and now we can't really aim our threaded brass inserts, and we're gonna guesstimate. I think you need 4mm holes or something, and these ones are just 3.5. So yeah, it's gonna work, but it's gonna suck. So the soldering iron is hot, and then I just heat up the piece, the part, the thing, and then because this is PLA, it should happen really quickly. And what you do is you don't slide it in completely, and then you take something flat and press it in so that it's flush with the surface. It's still hot, so take care, don't burn yourself, but also you have some time to wiggle it around until, you know, it sort of feels right. Here you can tell from the layers we have a 5-degree angle, so it's not flat. That's why it's a little bit harder for me to guess, but that seems about right. So of course, if you have more heat-resistant material, I don't know, ASA, ABS, something, it's going to take a little bit more time to melt, but it's the exact same principle. Just leave 1 or 2 millimeters and then press in with a flat surface. Okay, I think you got the gist idea. Gotta repeat that for all those sides and also for the back side holes here. Gonna be back in a second. Can we just appreciate how cool that looks? I don't know. Yes, we can. The black and gold, the black and brass, it just looks nice. Unfortunately, you're not gonna see those threaded brass inserts, hopefully. And yeah, we can go on to the next step, which is preparing this side here for the marriage. This one is going here, and all the wires need to get bent. I have actually built in cable management here. We got some latches, 1, 2, 3. We're gonna need zip ties for that. Hopefully it's gonna fit. I never tried it actually. Yeah, great. But we need to prepare this piece first. I'm sorry, I'm so excited. I just wanna, you know, see it in one piece, and then I end up forgetting all those steps. So here we have the reset button. It's required to actually get into programming mode for the Teensy board. You need to pull the reset pin to ground, and this is exactly what this button is gonna do. Okay, reset button is inserted. Next up, display. Now you can see I prepared this one already. There you go. Oh no, I lost one. Okay, let's hope that I didn't break anything. Okay, I lost two. Okay, no worries, no worries. There you go, as good as new. Display is in, and it's also almost straight. That's what I said about those low budget threaded brass inserts. It's not that easy to, you know, align them perfectly. But for now we have a display, we have the button. So wires to the bottom here. Then we can install this piece, which is going on that way. Oh, I need to... Did I just... Good job. Okay, I inserted the threaded brass inserts from the wrong side. Now we're gonna learn something today. How do you undo threaded brass inserts? It's almost the same as putting them in, but you're gonna look like a moron because you didn't think about how which direction you're gonna put them in. What you do is taking the right size of screw, and then you know, you screw it in, then you heat it up and take it out. As simple as that. Maybe this should be enough. Yeah, that's it. Oops. So number one, 3 more to go. But this time I can just fast forward. Okay, just act like nothing happened. So this is my board, goes in that way. So I'm not sure if I actually can use all 4 holes, which is fine because I only have 2 screws left, right? I think one of the most important screws is the one here in the top right corner, because this is the one closest to the USB port or micro USB thing. And then I will use the rules of diagonal things, because that's how rules work, right? And this screw aligns perfectly, so I'm going to try to fit in a larger one and see what happens. Yeah, it works, I guess. Maybe even, yeah, this hole we can make it work. Maybe. Yeah, I just broke it. I was talking so much about threaded brass inserts. Of course, they are completely useless if you mess things up, and I definitely did. I made the holes for the 3mm screws too small and the holes for the 2mm screws too large. Well, it sort of works because it's a very, very forgiving process, but yeah, now this thing is grinding hollow and it's annoying. So what are we going to do? Yeah, I know. Act like it didn't happen. Of course, flawless process, right? And the most interesting thing here is that I'm still not sure if everything is going to fit. Well, this is actually also something you should find out before you spend that much effort into a project. However, I actually never calibrated my CNC machine. Because in the instruction it never told me to calibrate. I know it's not perfect, but I hope it's gonna be, you know, sort of accurate enough to, well, to more or less fit together. You know what, I'm just gonna screw it in and keep my fingers crossed that everything is gonna be fine. That's basically also how I go through life. Oh, looking good, looking good. Okay, now let's not mess this up. So considering that this is my very first project with a CNC machine, I think it's turning out really nice. Again, you can see here the gap. So the pieces which come out of my CNC machine are currently a little bit too large, like 1 or 2%. To be honest, I love the unfinished look. Just look at it, how self-made it looks. I think it's gonna be a really cool thing once it's done. Here you can see, because of the interlocking things here at the moment, we have a little bit of a bend. I hope once I have the exact same inaccuracy on the bottom side, we're gonna unbend it again. Otherwise, gravity is going to do its job anyways. We need to finish the wiring here. Yeah, the reset button is gonna be easy. Plug it in here. There you go. Okay, I just finished wiring up the first JST connector, and then I realized that I forgot to plug in my microphone. Luckily we have like a bunch of more cables to go, so I can explain everything again. Basically I was trying to explain to you how I personally use JST connectors. But because I already had 5 things to practice, we can make things a lot speedier. Red, brown, purple and yellow. Red, brown, purple, yellow. I'm just trying to plug them in the direction they're or in the order they're coming from. That way it's going to be easier for me to you know, to think. Once they're cut to length, it's best to strip them a very short piece, just like 2 millimeters, like so. So now we're gonna have a look at those, I don't know how they're called, brackets. These are the things which you need to, well, clamp around your wire. I don't know if you can see it, but we have 2 sets of wings, 2 very short ones and 2 longer ones. What I do is I put the wire inside, and then I use the shorter ones to, you know, grab the stripped piece of the wire, which we just strip off, and I'm going to use the longer ones to grab the wire with the insulation. So this is a process which is very hard to get on camera. I hope you can imagine what I'm doing right now. Yeah, it takes a little bit of patience and skill to make nice bends, but you know, after 3 or 4 you're gonna figure out how it works. Then it's gonna be easy. So I'm going to repeat these steps again, and then I'm gonna come back once I'm done here. And well, here it is. All those wires now nicely tucked in where they belong. Well, basically we would be done with the hardware side. Well, I haven't powered it up yet. That's because I still need to write all the software. Actually, there is pre-configured software like QMK and all that, but I'm not even sure if it's compatible with my microcontroller. I'm going to write my own Arduino code because, well, this project has been taking detours for the sake of doing it yourself, so I might as well just write my own code. So maybe one day I will take you along with the coding part, but as far as I can tell, it's gonna be very boring for most of you. So yeah, I'll be back. I finished up the bottom and I posted a separate video about that. You can check it out in case you missed it. In that video you see me using the milk and honey keycaps, but look at that. I bought a set of beautiful side printed keycaps, and I think they complement the stealthy look a lot. Yeah, I think it's a really nice keycap set also. To keep this video short, I'm not gonna spend too much time talking about the features and macros and all that. Instead, I'm going to display a table here in front of my face, and you can pause the video in case you're interested. Overall, it's been a bumpy ride, seriously, but I think I just love this keyboard here. It's really great, and I can really see myself getting along with the CNC router. Also, if you listen closely, you can hear my wallet crying right now because it really got me into the hobby of mechanical keyboards. You should make sure to be subscribed in case you're also into that kind of stuff, you know. So, as always, I hope you had fun watching the video, and see you guys in the next one. Bye bye.